All right, hi everybody. So in this video here, we're going to solve this inequality, negative 2 multiplied by x minus 2 squared multiplied by x plus 3 cubed. And the nice thing about this thing is everything is on the one side. It's all factored. So I can tell you right now that if I was to look at this function here, negative 2 times x minus 2 squared times x plus 1 cubed, I know that my x-intercepts are going to be where x is equal to positive 2 or negative 1. That actually allows me to do a really quick sketch of this. And then from there, I can interpret the inequality. So I know this is a fifth degree polynomial because if I sum the degrees of those two factors there with the x in them, I'm getting a 5 there. So I know this is a fifth degree. I also know it's got a negative leading coefficient, right? That's that negative 2 out front there. So I know that the general motion of this thing is going to be down as I move to the left to right. So I've got this negative 1 x-intercept and this positive 2. And I know that the graph starts high and is going to start coming down. So it's going to approach that negative 1 x-intercept here. Now, it's got a multiplicity of 3, that factor. So the graph is going to come down. It's going to kind of level out, almost as if it's like a quadratic multiplicity here, and then pop back up. But actually what it does is it passes through. It kind of levels out and then passes through, comes up. And then when it approaches the 2, and actually it looks terrible there, but try that again. It's going to come down, and then it's going to approach the 2. But the 2 here has a multiplicity of 2. That's the exponent. So it's going to come up and kind of be tangent to it and go back down. And so that's roughly what my graph is going to look like. And so now the question is, where is the function positive? Where is the function greater than or equal to 0? And so that's going to be true here, where it is clearly above the 0. But because I'm including the 0, it's going to include that negative 1, and it's also going to include the 2, that interval there. So it's going to be where x is less than or equal to negative 1, union x is equal to 2. Now, if I was to put that into interval notation, I might write it like this. It's going to be negative infinity to negative 1, and I'm going to include it, union, and then I'm going to put a little set notation here, just so that we're including those two sets here. It's the union of them, that interval and that little set there, just the one number. And there we go.